Linear equations. So an equation indicates that two algebraic expressions are equal. A linear equation in one variable is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers and a is not equal to 0. So let's look at our first example. We want to determine whether the equation is linear or nonlinear. For the first example, we have ax squared plus 4x equals 62. Now this is an example of nonlinear. The reason why this is nonlinear is because your x term is squared. So this is in fact a quadratic. This is not linear. Now if we look at the second example right below, we have 4x minus 1 over x plus 12 is equal to 3. Now this is another example of a nonlinear equation. The reason why this one is nonlinear is because it has a restriction on your x term. So for this one, x cannot equal negative 12 because it would make your denominator equal to 0. And anytime you have a restriction like this, it would be nonlinear. Now the third one is 9x minus 13 is equal to pi x minus 2. Now if you look at this example, although pi is an irrational number, it is being multiplied by x, and both of your x's are held to the first power, and then you've got your terms, your negative 13 and your negative 2. So you could move over this pi x and it would be in the ax plus b equals c form. So this one is in fact linear. Now I do want to take a second to just show you one more example, and this is one that I've noticed quite a few people get wrong in the homework in the past. So this would be one where you've got, let's say, the square root of 6x plus 2 equals 3. Now this one is in fact linear because the x is not contained within that square root. So the x is not in the radicand, meaning it's not underneath the square root. That is why this one is linear. So your a term is the square root of x, your b is 2, and your c is 3. So it is therefore linear. So just make sure, especially in my math lab, that you pay careful attention to that, because it's very easy to misread the problem and think that that x is underneath that square root sign. All right, now the next one involves solving linear equations. All right, so we're looking at two examples. We'll work the first one first. It's negative 4x plus 1 minus 4 parentheses x plus 1 equals negative 6x plus 1. All right, so the first thing I want to do is I want to distribute this negative 4 to each of these terms. So that gives me, I have negative 4x plus 1, just rewriting the first part. Now I distribute that negative 4, so that's negative 4x minus 4 is equal to negative 6x plus 1. So be very, very careful. A very common mistake that I see on that first test is people failing to distribute the negative 4. They distribute the 4 to each term, but forget about that negative sign that is in front. So be very careful of that. All right, so now I'm going to go ahead and combine my like terms on the left side. So I've got negative 4x and negative 4x. That gives me negative 8x. And I've got the plus 1 and the minus 4. That gives me a negative 3. is equal to negative 6x plus 1. Now what I want to do is I want to move everything that contains an x to one side of the equation and everything that does not contain my x variable to the other. So what I'll go ahead and do is I'm going to add 6x to both sides. That gives me negative 2x minus 3 equals 1. And now I'm going to add 3 to both sides. And that gives me negative 2x is equal to 4. Now my last step here is to divide both sides by the coefficient in front of my x. So I'm going to divide both sides by negative 2. And that gives me x is equal to negative 2 for my solution. Now please keep in mind that you always want to check these answers to make sure that they hold true. So you can always plug in that x equals negative 2 into your original equation. So into your original equation to see if that gives you a true statement. Alright, so now let's work that second problem. I'm going to try to color code as we go along to try to simplify what we're doing and help everyone see what's going on. Now if you look at question 2, it says 2/5 x is equal to 3 plus 1/3 x. Now for most people tend not to like fractions. So what we're going to do is we're going to get rid of the fractions. And we're going to do that by multiplying both sides of the equation by the least common denominator. Now your least common denominator here would be 15. So what I'm going to do is I'm going to take 15 and I'm going to multiply it by 2/5 x. Say that is equal to 15 times 3 plus 15 times 1/3 x. So I just took both sides and multiplied it by 15. So I had to take the 15 and multiply it by the 3 and the 15 multiplied by the 1/3 x because I had to distribute that 15. So that's where those values come from. Alright, now the whole idea of why I multiplied by the least common denominator is so that I could get rid of those fractions. So if I look, I see that 5 goes into 15 3 times. And then over here, 3 goes into 15 5 times. So I'm left with 3 times 2x, which gives me 6x, is equal to 15 times 3, so 45, plus 5 times 1x, so 5x. At this point, it looks very similar to the first example that we did, where I need to move all of my terms containing x to one side, and everything that does not contain x will be on the other. So from here, that just simply means I'm going to subtract 5x from both sides. And that gives me x is equal to 45. Once again, you always want to check these. So what I mean by checking them is you're going to take that x equals 45 and plug it into that original equation. I'm going to go ahead and take a minute just to show you an example of what that looks like. So I'll go ahead and put it in green. As far as checking answers, that means I've got 2/5 times 45 equals 3 plus 1/3 times 45. Alright, so I know that 5 goes into 45 9 times. I know 3 goes into 45 15 times. So I have 2 times 9, I have 18 is equal to 3 plus 15. So 18 equals 18. I have checked my answer, and x does in fact equal 45.